This is one of the hardest SAT questions I've ever seen. This is from Non-Adaptive Digital SAT Test 4, Module 2, Question 21. It reads, two identical rectangular prisms each have a height of 90 centimeters. Okay, cool. So we've got rectangular prisms. You might refer to your formula sheet. We've got a little bit of length, width, and height on our hands. Rectangular prism, we have ourselves a shoebox, and the height is 90. The base of each prism is a square. All right, so we're going to modify this a little bit. So here we are. And the base is a square. So that and that, let's both call them both the length. The length and the length are the same because we're dealing with a square here. And the height is 90, okay? And so we have two of these. Interesting. And they say each has a surface area of k centimeters squared. So surface area equals k centimeters squared. That's true for both of them. Now let's start to dig in a little bit further. Ask yourself, what does surface area mean? Keep in mind, you can look at the picture on the provided aid formulas that the SAT gives you, but it only talks to you about volume. We're not talking about volume here. We're talking about surface area. So it's kind of like if I spray painted the exterior of this shape, of this rectangular prism, what sort of shapes would I see? What sort of area would I have? How much paint would I use? Or how much material, if this was a room that I was building, is there? Well, the top and the bottom, those are squares. You could even draw them if you feel so compelled, that are length by length. There are two of those. Area of a square is length times width, or side squared. The side is L. So if we start building up the surface area of just one of these prisms, one of the squares is L squared, but there are two of them. Okay, so that's top and bottom. Now, also since it's a square, you have these four faces that are each L by 90. You've got the left, the front, the right, apparently I'm inverted in my brain, and the back. So there are four rectangles, length times width. That'd be 90 times L. Now, if you want, we can clean this up a little bit. That's 2L squared plus 360L. That's the surface area of one of our rectangular prisms. So that's also K, just for reference, okay? Now we're going to have two of these, and we're going to glue them together along the square base. So here's one. We're going to attach it like so along the square base, the L by L base. And now if we were talking about the surface area, what would we spray paint if we sprayed the exterior of this? This sort of wall from each of the rooms that we're putting together does not touch the air anymore. It's not part of the surface, so it's not part of the surface area. So we're actually losing one of the L squareds from each of the shapes. So it's kind of like, don't use that on one of the shapes, and then on the other one, same thing. We're throwing that out because it's no longer part of the exterior. So the new surface area, let's sort of crunch the numbers there. So we lost these L squareds, but that's okay. We still have an L squared there and an L squared there. So we have two L squareds again, the area of two squares, the top and the bottom. Now we have four rectangles that are each L by 90 plus 90, which is 180. That area is 180 L. So there's four at 180 L apiece. So our new surface area is 2L squared plus 720 L. Okay, now we have our next clue. The resulting prism has a surface area of 92/47 K. So this is equal to 92
47ths k. So now we have essentially two equations here. Now, I'll include a link to this in my YouTube video, but the digital SAT now has DESMOS as a calculator in the upper right-hand corner of the screen baked in. So this looks like a job for Delta. And I said Delta, excuse me. Delta Math is incredible. But for DESMOS, DESMOS's online calculator will help us solve this problem with ease. So this would not be fun. This would not be fun otherwise. But so we essentially have two equations.
I immediately think, hey, this could be a job for DESMOS. I don't want to have to do anything out that I don't have to. I don't want to use my calculator. I'd rather just use the baked-in computer software associated with this. So if we clean this up a little bit, you'll see this is really just a system. Now, I'm going to show you a couple of ways that DESMOS can handle this. But so essentially we have two variables. We have L and K. So, and we have two equations. So this is a system with two unknowns. Now we could feed this. We could feed this as is to DESMOS. I won't say Delta again, even though Delta Math, shout out to Delta Math, it's an incredible tool. We could feed this to DESMOS as is. I'll show you that at first. It's a bit ugly. Now notice we can substitute in for K. So in place of K, we could plug in 2L squared plus 360L. Now we can solve this much more easily in DESMOS. Now, if you wanted to do it how a teacher might want you to do it in like an Algebra 2 class, you could kind of grind it out and use up, I could use up a bunch of paper and we could go that long way. But the SAT is a game, and you have this powerful tool of DESMOS. And now I'm going to switch over and I'm going to show you at first solving this way. And I'll show you that it's kind of terrible. So then we'll solve this way. But if this is like a public service announcement, if you are going to use DESMOS, you can't use L's and K's. You can't use L's and K's. So I recommend going in alphabetical order. There's K and there's L. I recommend plugging in either K for X and L for Y, or vice versa, before we turn this into what we're going to feed DESMOS. You have to change it to X's and Y's, otherwise it's going to think you're dealing with constants, and that's going to be a big mess. So now I'll show you how to use this using DESMOS to save as much time, because this test is a game, and I'm going to show you how to play it as effectively as possible. Right, so I'm at desmos.com. I go to Math Tools, Graphing Calculator. This is actually baked in, again in the upper right if you're practicing on Bluebook, which you should be doing quite often. It's baked in to your digital SAT. You can just use it. It's right in line with the problem. It goes to the left of the problem. It's absolutely incredible. So let's get typing here. So I had mentioned if you type an L, it's going to ask you for a slider for L. We don't want that. You could either have, it doesn't matter how you do it. You could have LBX or KBX. So let's say L is X. K is Y. Okay, cool. There's one equation. And then we have 2x squared plus 720x equals 92/47 y. Now make sure the y is right after it. So it is effectively in the numerator. It's the same thing as reading it like so. Don't have it in the denominator. We are dividing by y. We're multiplying by y. Okay, so if you try to solve this, like to look for their intersection, things look particularly horrific. I'm super zoomed in. You could zoom in a little faster. Like this looks like a mess. Oh, there's some things. So trying to find this point of intersection, it just seems really, really terrible. This is not a ringing endorsement for DESMOS just yet. But if I take this and I copy this and I substitute, I'm going to substitute in place of y 2x squared plus 360x. Then this will be much easier to solve. Now we've used substitution. We substituted the first equation into the second equation. I mentioned this earlier. Now what we're doing is we're just finding the solutions. And it's so beautiful. 0, that's not going to be helpful. If you look at the answer choices, we're solving here for x, which I had be L. I modified from what I was thinking earlier. X is L, the length. The problem says what is the side length of each square base. We call that L. In this case, it's X. X is 8, and that is answer choice B. So you can use DESMOS to help you. But notice how horrific the intersections were before. This is much more manageable, and I think they tried to make it as terrible as possible so that you couldn't use DESMOS. But like, just imagine that you were writing this down on paper and distributing and solving this quadratic using the quadratic formula. That's a time sink. There's room for error. That's absolutely horrific. Instead, use DESMOS. You should honestly use it for 90% of your questions that you're solving and or checking. So it's a tremendous tool. And again, we get x to be 8. That was the length of the base, which is what the problem was originally asking for. So answer choice B is the winner.
So in the end, we got L was 8. What is the length of each square base? That's what we defined as L. The length is in fact 8. So we have answer choice B. Now actually modified, it would have been fine the other way. And I felt like I was going to scrap it, but I just kind of went with it. I actually modified my thinking. I made the length be X and K be Y, the second variable. That worked out quite well. If you think about it, typically you're used to sort of Y being by itself in the equations that you're solving. So that's kind of why I made that choice. Now, if you were to do this the long way, and maybe these were X's in your world, I mean, this would just be god awful. Like, do you really want to solve this quadratic? Do you have that kind of time when you're taking the SAT? No, absolutely, of course not. Absolutely not. Like to distribute, yada, 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 get everything a quadratic set equal to 0 and do the quadratic formula or feed that to your calculator. Don't bother. So I've shown you the most efficient way to answer this question, and I think this is one of the more involved SAT type questions. It seems like they're getting more into surface area and new and interesting and different equations that they haven't really gone hard in the paint on. But try to ask yourself as much as possible, can I use DESMOS? It will change your score dramatically and maybe even change your life, depending on what sort of doors and opportunities that opens up. Be well. Have a beautiful day.